In the desolate expanse of Starbase, South Texas, where the Rio Grande meets the restless Gulf of Mexico, a steel colossus stands poised on orbital launch pad A, its silhouette a stark defiance of the gathering dusk. The Super Heavy booster B-15, a veteran of Flight 8's daring tower catch, and the upper stage ship S-38, the final iteration of SpaceX's Block 2 design, have been meticulously stacked in a ballet of precision that belies the chaos of the cosmos they aim to conquer. On this evening of October 13, 2025, at 7:09 p.m. Central Time, the countdown to Starship Flight 11 ticks relentlessly towards zero, each second heavy with the weight of ambition and dread. Engineers, cloaked in the sterile glow of mission control monitors, have spent weeks orchestrating the final preparations, but as the launch window looms, anomalies in the data, whispers of instability, cast a shadow over the Enterprise. What secrets does this towering machine harbor, and will they unravel before the fiery ascent? The chapter begins in the pre-dawn hours, where the air at Starbase hums with the low-frequency thrum of cryogenic pumps, flooding the rocket's cavernous tanks with liquid methane and oxygen, chilled to minus 183 degrees Celsius. These cryogenic proof tests, critical to ensuring the structural integrity of the stainless steel hull, push the vehicle to its thermal limits, where even a microfracture could spell catastrophe. Data streams from embedded sensors confirm the tank's resilience, yet engineers note subtle pressure fluctuations, oscillations that deviate from the expected by fractions of a kilopascal. These are dismissed as artifacts of ground equipment, but the anomalies linger in the logs, a quiet warning that not all is as it seems. The narrative weaves through the pad's infrastructure. Towering cryolines snake across the launch mount, their surfaces frosted with ice, while autonomous drones sweep the perimeter, their LiDAR beams slicing through the pre-dawn mist to map the stack's alignment down to the millimeter. As dawn breaks, the focus shifts to the static fire test, a ritual of controlled violence where all 33 Raptor engines ignite in unison, unleashing 7,590 metric tons of thrust in a roar that rattles the wetlands and sends egrets scattering. The ground shakes as if protesting the audacity, seismic monitors registering tremors equivalent to a 3.2 magnitude quake. Spectral sensors, positioned miles away, capture the exhaust's chemical signature, methane combustion laced with trace nitrogen oxides, a testament to the engine's efficiency. Yet vibration analyses reveal a troubling anomaly: harmonic frequencies in the ignition sequence, resonating at 1.2 Hz beyond predictive models. These are not the clean, synchronized pulses of a healthy rocket, but a discordant hum, as if the vehicle carries echoes of its prior flight's near disasters. Engineers huddle over oscilloscopes, their faces illuminated by flickering screens, debating whether these are benign relics of wear or harbingers of structural fatigue. The data is archived, but the unease persists, a reminder that Starship, for all its engineering marvels, dances on the edge of chaos. Drawing on telemetry from August's Flight 10, where booster B-14 achieved a historic soft splashdown in the Gulf, scientists dissect the upgrades that define Flight 11's ambition. The heat shield, a mosaic of 18,000 hexagonal ceramic tiles, has been reinforced with a new zirconium-based coating, designed to withstand the 1,650 degrees Celsius plasma inferno of re-entry. These tiles, each bolted with precision to the upper stage's underbelly, are the culmination of years of iterative failure. Flight 7's catastrophic tile loss at Max Q, where hypersonic winds stripped the vehicle bare, remains a haunting lesson. Modified chill lines, now insulated with advanced aerogel composites, aimed to prevent the explosive ruptures that doomed Flight 9 when a liquid oxygen leak ignited mid-ascent, shredding the booster in a fireball visible from Corpus Christi. The narrative lingers on these improvements, juxtaposing the cold precision of engineering against the raw violence of their testing grounds, where scorched earth and twisted rebar mark the pad's battle scars. Grainy drone footage, captured under floodlights that bathe the stack in an otherworldly glow, amplifies the isolation of Starbase. The rocket's welds, visible as faint seams along its 120-meter height, seem to shimmer with tricks of shadow, as if the hull itself breathes under scrutiny. This frontier outpost, far from urban sprawl, feels like a citadel on the edge of the unknown, its barbed wire perimeters patrolled by security teams, wary of espionage or sabotage. The Federal Aviation Administration's notice to airmen, NOTAM, has sealed the airspace for a 50-mile radius, grounding commercial flights and casting an eerie silence over the Gulf. The U.S. Coast Guard, enforcing a maritime exclusion zone stretching 20 nautical miles, reports no vessels in violation. Yet the emptiness feels oppressive, as if the sea itself holds its breath. In mission control, a bunker buried beneath earthen berms to shield against a launch failure's blast radius, data streams flow without interruption. Fuel pressures stabilize at 6 bar. Avionics report green across 12 subsystems. But veteran analysts, some with decades at NASA or Boeing, exchange uneasy glances. Outlier readings in the fuel mixture ratios, methane slightly over-enriched at 3.2.1, defy the expected stoichiometry, a deviation small enough to ignore, yet persistent enough to nag at the edges of confidence. The wet dress rehearsal, completed at 3:00 a.m., simulated the full fueling sequence, pumping 4,800 metric tons of propellant into the vehicle's bowels. The test was flawless by official metrics, with no leaks or valve malfunctions. Yet the telemetry logs preserve a curious artifact: faint electromagnetic echoes, pulsing at irregular intervals, detected by ground antennas. These are dismissed as interference from Starbase's Starlink relays, but their frequency, 2.4 GHz, aligned with no known equipment, eludes explanation. The narrative heightens tension through these subtle cracks in the facade of control, painting a picture of a team on the brink of history, yet haunted by variables beyond their grasp. The rocket stands sentinel against the horizon, its silhouette a monument to human audacity, but also a reminder of fragility. Each component, from the Raptor's turbopumps spinning at 20,000 RPM to the grid fins poised to guide the booster's return, has been tested to failure in labs from Hawthorne to McGregor. Yet the whole is more than its parts. And the anomalies, those harmonics, those ratios, those echoes, suggest a system straining against the unknown. As the countdown clock dips below T-10 minutes, the atmosphere in mission control thickens with anticipation and dread. Engineers monitor real-time feeds from Wahoo 200 sensors embedded in the stack, tracking everything from tank ullage to flap actuator response times. The vehicle's autonomy, governed by neural networks trained on petabytes of prior flight data, is designed to react in microseconds to anomalies: a stuck valve, a pressure spike, a sudden yaw. Yet, human intuition, honed by years of wrestling with the unpredictable, senses something amiss. The electromagnetic echoes, now cross-referenced with Flight 10's logs, show a pattern: brief bursts, almost like signals, coinciding with engine throttles. Are they benign? A quirk of overworked antennas? Or do they hint at an interaction between the rocket's systems and an external force, undetected by radar sweeps? The narrative closes on this precipice, with the launch director's voice steady but strained, calling for final go, no-go poles. Outside, the Texas sky darkens, stars piercing the twilight as the rocket looms, a silver spire ready to ignite or implode.